Hello dear students, today topic I am going to explain a solid state. So about the solid state, in this today lecture we will discuss completely basics will be discussed, and after this lecture we will be entering into the mainly a solid state topic. So today lecture completely basics related to solid state topic. So now the solid state topic as a basic point is start from the matter. So matter mean everyone knows which is occupy the space and has the mass, such type of substances we call as a matter. And this matter is dividing into three types. One is solid and another one is liquid and another one is a gas. So totally the matter is dividing into three types: solid state and the liquid state and the gaseous state. From school level also it is coming the repeatedly matter dividing into, we are saying solid state, liquid state, gaseous state, solid, liquid, gaseous. So every time we are repeating these points. So now here how the matter is dividing into these three different type mean depend on the arrangement of the particles in the matter. In the matter, the particle arrangement is very close to each other. The resulting state we call as a solid state. In the matter, the particle arrangement is some distance maintaining each other. The resulting substance is liquid state. In the matter, the particle to particle very large distance is the resulting state is a solid state. So if you see here, solid state nothing but we discuss in a matter, the particles are very close to each other. For example, I am taking this is the matter. Here the particles are very close to each other. See here. So these are everything is the particle. These particles are very close to each other. That means there is no distance maximum. So the particles are very closely present to each other. The resulting state we call as a solid state. So if we come to the liquid state, here also particles are there, but particle to particle some distance is present. Particle to particle some gap or some distance is present. The resulting state we call as a liquid state. And if you take the gaseous state, in a matter, the particle to particle a large distance is present, resulting of that gaseous state is possible. It means depend on the particles arrangement in the solid, the matter is dividing into three types: solid state, liquid state and a gaseous state. But again this solid state or this solid we are dividing into two types. This solid again we are dividing into two types. One is amorphous form and another one is a crystalline form. So let us discuss the solid, why it is dividing into two types and based on what factor the solid is dividing into two types. Let us discuss here. The solids are dividing into two types. Here the solids are dividing into two types. One is a amorphous form and another one is a crystalline form. Here the solids are dividing into two types. One is amorphous form and another one is a crystalline form. So I am writing here, one is the crystalline form and another one is amorphous form. So let us see that here why the solid is dividing into two types. So already we discussed that matter mean anything which occupy the space and matter, and anything which occupy the space and mass, and the matter is dividing into three types: solid, liquid and gas. Depend on the particles arrangement is very close to each other, the resulting state is solid. But again the solid state is dividing into two types. What is that? One is crystalline and one more is amorphous. So how we are dividing the solid into crystalline and amorphous, I can take or I can explain with the help of a small example is a chalk. If you see the chalk, generally chalk is made by the calcium carbonate, right? So and one more example which is made by the calcium carbonate, for example marble you take. So marble also made by the calcium carbonate. But if you see the chalk and marble, we can break the chalk easily, but we cannot break the marble easily. But it is also made by the calcium carbonate and the marble also made by the calcium carbonate. We can break the chalk easily, but we cannot break the marble easily. So what is the difference? Mean the arrangement of the particles. Arrangement of the particle. So due to the arrangement of the particles in the chalk and in the marble, one of the substance we can break easily, other one you cannot break easily. So depend on the arrangement of the particles in the solid is dividing into two types. One is the crystalline solid and another one is amorphous solid. Example of the chalk is example of amorphous solid and the marble is example of crystalline solid. So now what is the arrangement in the crystalline, what is the arrangement in the amorphous, let us discuss. So crystalline solid is forming by the regular arrangement of the particle. The crystalline solid means what? Regular arrangement of constituent particles. Regular arrangement of constituent particles is present. That is called as a crystalline solid. In a solid, the constituent particles, if it is follow a regular trend or regular arrangement, if it is follow, the resulting solid is a crystalline solid. And in a solid, the constituent particles, if it is not in a regular arrangement, we can say that is amorphous solid. So not a regular arrangement, we can say that is not a regular arrangement. Not a regular arrangement of constituent particles is called as amorphous. The regular arrangement of the constituent particles is present, that is a crystalline solid. So what is the meaning of regular arrangement? So how can you say it is a regular arrangement, it is not a regular arrangement? So come to here. For example, I am taking a solid, everything is made by the particles. We discussed that either solid state, either liquid state, either gaseous state, whatever the state you can take, it is made by the particles. Same here also, solid is made by the particle. I am taking crystalline solid and amorphous solid. So if I take the crystalline solid, the particles arrangement, how it is, let us see. So first one, for example, A is one of the particle, and the next one is B, and the next one is A, and the next one is B, and the next one is A, and the next one is B. So this is the arrangement of the particles in the crystalline state. What mean? A, B, and A and B. It means it is following a regular trend. See here. A, after A, what is coming? B. After B, what is coming? A. After A, B. After B, A. After A, B. So it is following a regular trend. A, B, A, B, A, B. It is following a regular trend is following. Such type of regular trend, if it is follow, such type of solids we call as a crystalline solid. And amorphous solid we discuss not a regular arrangement, not a regular trend. That means after A, maybe B will come, again B will come, maybe again A will come. So it is not following a regular trend. So for example, I am taking this is the A. After A, maybe B will come or maybe A will come. So for example, I am taking B. After B, again I am taking A. So maybe again I am taking A, again B I am taking, again B I am taking. So we cannot expect what the next is coming. Such a type of arrangement, if it is there, that is called as a amorphous solid. So for example, if you see that crystalline solid example is sodium chloride. Crystalline solid example is what? Sodium chloride. For example, I am taking a crystal, I am taking here. For example, I am taking a crystal, I am taking. This is the sodium chloride structure. It is the sodium chloride structure. So for example, if I see here Na plus is present, here Cl minus, here Na plus, here Cl minus, here Na plus, here Cl minus, here Na plus, here Cl minus. Mean what here? A regular arrangement is there. So for example, this is Na plus, it will be Cl minus. If it is Cl minus, it is Na plus, it is Cl minus. If it is Cl minus, it is what? Na plus, and it is what? Cl minus, and it is what? Na plus, it is what? Cl minus. Let us see that here. One after NaCl, what is there? Cl minus. After Cl minus, what is there? Na plus. After Na plus, what is there? Cl minus. So one Na plus, next Cl minus. Again Na plus, again Cl minus. A regular arrangement is forming. So such type of solid, what we call a crystalline solid, we call. But in the amorphous solid, there is no regular trend. Any way also it can be present, right? So now maybe here I am taking B, maybe B possible, maybe A, again B, again A, again A, and again B. So whatever the order is follows. So it is a amorphous and it is a crystalline solid. So example of the amorphous solid is plastic. We can take example of the amorphous solid. At the same time, glass we can take. And here crystalline solid, diamond, graphite, sodium chloride. So these all are what crystalline solids will come. So next one, here amorphous solids we call as a pseudo solids. Amorphous solids we call as a pseudo solids. Amorphous solid we call as a pseudo solid. Otherwise we call as a super cooled liquid. Super cool liquid. Amorphous solid we call as a super cool liquid. Otherwise pseudo solid. But crystalline solid we call as a true solid. Crystalline solid we call as a true solid. So why we call as a true solid and why we call as a what amorphous solid as a pseudo solid or super cool liquid will be discussed. So true solid nothing but the arrangement of the particles is regular. So that's why we can say it is a true solid. But arrangement of the particles is not a regular. It means it is not a true solid. Mean why we call super cool liquid, let us discuss. For example, I am taking a glass. For example, I'm taking a glass. I'm taking, generally we are arranging to the windows, a large glass I'm taking. When a freshly prepared glass, if I see, the top edge of the glass is 1 mm is present, and the bottom edge thickness of the glass 1 mm if it is present. After 10 years, after 15 years, if you observe the same glass, after the 10 years or after the 15 years, if you observe the thickness of the glass, at the top edge thickness and bottom edge thickness, if you observe, the top edge thickness may be 0.95 mm is present, and the bottom edge thickness is maybe 1.05 mm is present. It means what happened at the starting state, the bottom edge thickness is less, it means 1 mm, but after some years the bottom edge thickness is slightly increases to 1.05 mm, for example. So why it is increases the bottom edge thickness and why it is decreases the top edge thickness? Nothing but due to the flow of the particles, So these are the glass particles are present. Slowly when the years are passing, the glass particles are very slowly, like a super cooled liquid, like the particles are slowly moving from top edge to bottom edge. Due to that reason, the bottom edge thickness is slightly increases compared to top edge. So that's why we call this is the super cooled liquid, and also we call it as a pseudo solid. But such a type of changing we cannot observe in the crystalline solids. That's why crystalline solids we call as a true solids. And one more important factor here, crystalline solid we call as a anisotropic. Crystalline solids we call as a anisotropic, but amorphous solid we call as a isotropic in nature. So why we call isotropic and anisotropic? Let us discuss here. Crystalline solids we call as a anisotropic in nature, and the amorphous solid we call as a isotropic in nature. One is anisotropic in nature, and another one is isotropic in nature. So why we call amorphous solids isotropic and crystalline solids anisotropic? Let us discuss in this session. In the chemistry, wherever the topic you can take, iso mean it is indicating same, and isotropic and anisotropic, what is the mean? We can explain with the help of one example. For example, I am taking a glass, I am taking, otherwise a solid I am taking. In this solid I am taking two directions I am taking. So for example, this is one of the direction and it is one of the direction. This direction I am taking as a A point, this is, and this is a B point, and this is the C point. So totally 3 points I am taking. One is A, one is B, one is C, and it is A to B direction and A to C direction. So amorphous solid means we can say isotropic nature. Isotropic nature means in a solid two different directions I am taking. One is AB direction, one is AC direction. In two different directions, the physical properties of the substances, if it is same, such type of nature we call as a isotropic in nature. In two different direction, the physical properties of the solid, if it is same, such type of character we call as a isotropic in nature. And if you come to the anisotropic, same solid I am taking. For example, in the AB direction and AC direction, if I see, the physical properties of the solid in AB direction and in AC direction is different. Like melting point, otherwise refractive index, otherwise maybe density. Such kind of physical properties in two different directions is different. Such a type of nature we call as a anisotropic nature. In two different directions also, the physical properties, if it is same, that is called as a isotropic in nature. So why the properties are different and why the properties are same here? So let us discuss. For example, I am taking what here? This is the arrangement of the particles in the amorphous solid. So amorphous solid, we discussed, there is no regular arrangement of the particles. So now, for example, I am taking, this is B, it is A. If I see this direction, first here B is there, next A is there, and the next we cannot expect what is coming because it is does not following a regular trend. Now I am taking in this direction, I am taking first B is coming, next A is coming, and before that, after that, what is coming we cannot expect because amorphous solid nothing but there is no regular arrangement. So it means I am taking two directions, I am taking one of the direction, the next atom or the next particle what is coming we cannot expect. and other direction also the next particle what is coming we cannot expect. It means in two different directions also the particle the next what is coming we cannot expect. It means in this direction we cannot expect the property. Mean the property we can say it is same in the both the cases. Here also we cannot expect, here also we cannot expect. It means the properties is what here both are same. Here also we cannot expect, here also we cannot expect. It means due to such a type of arrangement the physical properties of the substances in two different directions is also same. Such type of character what you call isotropic in nature. And anisotropic if you see here, so for example I am taking B, I am taking, and the next one is A, next one is B, after that A, after that B, again after that A. So it means it is following a regular trend, it is following. But if you see this is the B and this is also what B, and here if I see this is B and it is what A. So this is the B and the next particle is A, and after that we cannot expect what is coming, but here this is B and here also B, and the next particle also it will come as a B only. So it means one of the way we can expect the particle what is coming next, one another way you cannot expect the particle what is coming. So it means two different directions it is having two different kind of properties. Such type of properties what you call here anisotropic properties. So now crystalline solids are anisotropic. It means two different direction the physical properties are different, and amorphous solid is isotropic. It means two different directions it is having same properties. And one more here, temperature, melting point temperature. Amorphous solids is having a sharp range of melting point. Amorphous solids having a sharp melting point, crystalline solids having a sharp melting point, but amorphous solid having a certain range of melting point. Certain range of melting point. So what is the mean of sharp melting point and certain range of melting point? For example, iron I am taking. Iron is a what crystalline nature, and that iron generally melting point is nearly 1900 degrees centigrade. So at the particular temperature the iron can be melt. At a sharp temperature iron can be melt. But if we see that amorphous, for example plastic, it is start the melting from 40 degrees centigrade for example, and it will be continuously melt when the temperature is increases 50 degrees, 60 degrees, 70 degrees. When the 80 or 90 degree reaches, the complete plastic will be melt. It means the range of the melting of a plastic from 40 degrees centigrade to up to 90 degrees centigrade for example. So it is having certain range of melting point. So that is called as a amorphous solid is showing certain range of melting point, but crystalline solid is having a sharp melting point. So this is the characteristics of the amorphous solid and crystalline solid. These are the basic information. It is very important. Amorphous solid characters and crystalline solid characters are very important. So after the amorphous and crystalline solids here, the crystalline solids again we are dividing into different types. This crystalline solid we are dividing into different types. So let us discuss the crystalline solid. So it is dividing into how many types and what are that. So I am writing here crystalline solid. I am writing here crystalline solid. Crystalline solid is dividing into different types. In that first one is ionic solid. Crystalline solid is dividing into different types. In that first one I am writing as a ionic solid, and after the ionic solid the second one I am writing as a covalent solid. Ionic solid, and the next one is covalent solid, and the next one is a molecular solid. Otherwise you can take a ionic solid and covalent solid. Next one metallic solid also we can take, and the third one is metallic solid, and the fourth one is a molecular solid. Fourth one is what here? Molecular solid. One is ionic solid, one is a covalent solid, one is a metallic solid, other one is what? Molecular solid. So crystalline solids are dividing into these different types: ionic, covalent, metallic and molecular type. So now what is the constituent particles are present in these type of salts? Let us see. Constituent particles. In the ionic solid, the constituent particles are ions. For example, if I see that sodium chloride. Sodium chloride crystal nothing but what is the particles? Na plus is one of the particles, Cl minus one of the particle. It means in the ionic solid, the constituent particles are ions. In the ionic solid, the constituent particles are what? Ions. In the covalent solid, the constituent particles are what? Nanometals. Covalent solid nothing but what? For example, any one of the covalent solid. Covalent nothing but what? It is forming by the nanometals. So simply we can say covalent solid constituent particles are what? Nanometals. And metallic solids constrained particles is what? Metals, metallic ions, otherwise we can say metals. Fe plus 2, iron is a metallic solid which is having iron plus 2 ions. So constrained particles is what? Metal ions is a constrained particles. If you come to the molecule, what is the constrained particles? In the molecular solid, the constrained particles are molecule. For example, water in the solid state, if you take, what is the particles here? H2O, H2O, H2O. So in the molecular solid, the constrained particles are what? Molecules. So next one, if you see here, what type of bonds takes place here? What type of bonds takes place in the ionic solid and the covalent solid? If you see here, ionic solid, what type of bonds takes place? Due to the oppositely charged ions, the ionic bond can be takes place here. Ionic solid nothing but oppositely charged particles are present. Due to the oppositely charged particle, electrostatic force of attraction is developed. Resulting of that, ionic bonds are possible. Resulting of that, what bond is takes place? Ionic bond is takes place. If you come to the covalent solid, covalent bonds are present. Covalent bonds are present. If we come to the metallic solid, metallic bonds are present. Metallic bonds are present. And if you come to the molecular solid, generally van der Waals forces are present. What is present? Van der Waals forces are present. And if we come to the melting point, if we come to the melting point of the ionic solids are high, and the covalent solids are melting point is very high. Covalent solids melting point is very high, and a crystalline solid, metallic solid melting point is high, but molecular solid melting point is low. So why covalent solids melting point is very high? Mean due to the network structure. So covalent solids also we call as a network solid. So why network solid? For example, I am taking a diamond structure. If you take carbon, it is one of the carbon, and this is a carbon and carbon and carbon. So every carbon having the valency 4. So now it is forming the 4 bonds around it, and this is like a diamond structure. If you see here, this is one of the bond, it is one of the bond, this everything is the bonds. So now if we want to melt the diamond, we have to break this, all the bonds we have to break. So that's why we can say that compared to ionic compound, compared to metallic compound, the covalent solids are, it is having very high melting point. For example, diamond and graphite if you take. So this is the word, a complete characteristics of the water crystalline solids. Again, the molecular solids are dividing into different types, like a hydrogen bond containing solids, next of all polar solids, next of all non-polar solids. So this is a basic information completely related to solid state lecture 1. So in this lecture we discuss completely basic part, and the next lecture will be enter into a perfect ionic solid. There will be discuss a perfectly what is the characteristics of the solids and what is the relations, and everything will be discussed in the lecture 2. This is the session. Thank you.